Hey, everybody. Welcome to another Orchestructure event. My name is Mario Lorio. I appreciate all of you spending your evenings with us. As you know, Orchestructure revolves around DevOps, infrastructure concepts, SRE, and in this case, networking and the very popular Envoy kind of service mesh solution. Today, we have a very special speaker, someone who's here for the first time, to remind everybody, we are going to be taking a break. This is our last meetup for a little while. I think everyone is Zoomed and YouTubed and virtual meetups out. So we are going to take a little bit of a break. We will come back possibly sometime next year. But since this is kind of the last time we're talking to everyone, I want to say thank you so much for those that have tuned in every month that we've been able to do this. We've had a relatively steady stream of presenters who have come to us wanting to talk even in this time. And yes, Bob is very burned out. And by the way, we are going to use Slack, our Slack channel, #Orchestructure in the main A2 Slack network. If you want to ask questions or provide feedback or just tell Bob how great he looks today. It's you guys that make this possible. It's the reason that we've gone on this year doing virtual events. We very much considered not doing them. And how much value are people really getting? I think at this point we've done enough, and people are probably a little tired of these sorts of things. And so I think a little break is needed. And with the holidays coming, I just want to say from all of us at Orchestructure, I hope everyone has the best, safest holiday you can. And we all love you. We miss you. I'm really hoping, and the team is really hoping that we can do something in person, maybe in Q1 of next year. We'll see how things go. Obviously, safety is kind of our primary concern here. But I want to thank all of you. It really means a lot. The feedback, the tweets that I get, and we couldn't do this without you. So thank you for that, and thank you for tuning in. I'm going to shut my mouth. And as you can tell, I'm a great CNCF ambassador. KubeCon, Cloud Native Con, North America is coming up. We just got done with EU, and there's other reInvent and a ton of other stuff that's going on. EnvoyCon just happened. Try to stay involved with those things in the community and what's going on. And please ask questions of myself, Bob, Jeff, or George around Kubernetes. Bob just got into the steering committee, so quick clap for him. Please ask us things, thoughts, ideas. We want to still communicate as much as possible in Slack. I'm still doing, Google Meets with people in the evening sometimes, and catching up with long-term members and the people that have really helped us throughout the way find our way. So thank you to everyone. We hope you're doing well and you're staying safe. With that, I'm going to shut my mouth and give it over to Lawrence at solo.io. Take it away, Lawrence.
Awesome. Thank you, Mario. Let me go ahead and get my screen shared. Okay. Does that look good? Anything I need to change? Looks good? Okay.
Looks good.
Okay, thanks. So hey, everybody. My name is Lawrence Gadban. I am a field engineer at solo.io. And today I'm here to talk about Envoy and its role at the edge, its role in the service mesh, and everywhere else. And so, again, I'm from solo.io. We're a company that deals a lot with APIs, the challenges of moving to the cloud native type of landscape. And we have a few products that help with that journey. So again, I'm a field engineer at Solo. So really what that means is I'm out in the field, which really means virtually now, but working with customers, working with people that are interested in the tools, working with people that are interested in Kubernetes, and helping them, trying to help them on their journey that a lot of people are going on. And as we talk about that journey, this is kind of what this journey is really what we see. We have tons of folks coming to us that are going down something that looks very similar to this. And so in some form or fashion, there are lots of organizations that are going down trying to go from a monolithic type of infrastructure to a microservice-based architecture, right? And this has been going on for a while now, but it seems that we have tons of people reaching out that are in some phase of this journey. And whether or not, I'm sure microservices has been a very popular topic for quite some time now, and there are pros and cons to it, but there are some really valuable benefits that going to a microservice approach bring, and some of them are technical. So maybe that's you're talking about when you have 100 different pieces of functionality in a single application. If that's in a monolithic infrastructure, you have to, when you make a change, you're deploying that entire unit, so you're talking about batching up a bunch of changes and scheduling a Friday night deployment, right? And so microservices help with that type of, alleviating that type of need. And some of the benefits are organizational. So prior to Solo, I worked at a very large financial services company. And what you see in most organizations that I've worked with, and in my experience, is you have teams that are broken up, and the logical way of breaking up the teams is you give them a piece of functionality, right? So there's a search team or a billing team or whatever, right? And that just makes sense from an organizational point of view. And one of the things that going to a more service-based architecture enables is now you can say, okay, this team, the search team, they're going to own from top to bottom everything related to search or for billing or for accounts. And what that enables is now the teams can move at their own pace. And now they can make their own technology decisions, et cetera. And so there's a lot of benefit to doing that, because developer velocity is one of the most important things you can have, right? And happy developers is good for everybody. So there's a lot of reasons that people are going through this journey, but it isn't something that solves everything, right? So in this visual, we're looking at monolith to microservices, and then to throw another thing into the mix, right? You're talking various clouds, right? There may be different platforms in play, and this doesn't even include on-prem, right? You still probably have some on-prem stuff to worry about. And so what you need to consider, there are a lot of things that come into play when you're talking about going to this architecture. One of which is how do you manage API? So before, if you just had a single monolithic application, right, you didn't have to worry about, okay, now I'm exposing 20 different entry points into my infrastructure. And now you're exposing APIs, right? So you need to manage those APIs. And kind of along that same topic, how do you enforce security? Now you're introducing, 20 different entry points, 20 different APIs you're exposing. And if everything is a network hop, and you're jumping from on-prem to cloud and vice versa, right? Security is very important. And so you need to be sure that you're properly enforcing your security. And that obviously changes based off your organization, but I would be very surprised if you don't have, more security constraints or more security concerns when you go to a cloud native microservice type of deployment. And then one of the other things that's important is how do you observe this? So, what used to be just a bunch of function calls or whatever in a single application, now you're talking about 20 different service hops, right? So 20 different network hops. You're jumping to different pods if you're talking in Kubernetes, right? You maybe go in from on-prem to public cloud, and you need a way to observe all of that traffic. Again, coming from my previous employer, when you're trying to troubleshoot an issue that's related to a microservice style deployment, it can very quickly get very overwhelming and very hard to troubleshoot. And so you need tools to help you with the fact that, okay, now I have, I need to look in 20 different places to figure out what's going on. And so, with these challenges that come with the microservice style architecture, one of the common tools that has come into play is the service mesh, right? And service mesh is something that's also become very popular. And it's something that, it's very hype right now, which is great. I mean, it's an awesome piece of tooling. And the way that it works, kind of at the high level, right, is if you have a bunch of services talking to each other, right, the service mesh is trying to solve all of the challenges we were just talking about by putting a piece of networking, software that lives alongside your application, right? So in this diagram, this is kind of the standard Kubernetes and Envoy deployment, where you have a Kubernetes workload. So, you have a pod, right? You have your application container running in Kubernetes pod. And then alongside of it, and kind of the sidecar pattern, is an Envoy proxy. And this helps because now you have the Envoy proxy that's responsible for all of the network communication between these various services. And this is a nice solution to trying to solve kind of the distributed service model. In order for this to work, though, you need to give the Envoy proxies, or if you're not using Envoy, that's fine, but you need something that drives the configuration for these proxies, these sidecar proxies, because they need to know the state of however you're configuring your infrastructure. They need to be able to inspect your infrastructure in order to understand what can I even route to. How do I find these various locations that I need to route to? And so that's the job of the control plane, right? So the control plane is something that will watch the underlying infrastructure. So if we're talking Kubernetes, the control plane is something that's inspecting, or it's talking to the Kubernetes API, and it's getting relevant information for one, how do I configure my mesh, and two, what services do I have available, right? What endpoints do I have available to route to? And the control plane is responsible for understanding that and sending that data to these sidecar proxies so that they are as up to date as they can be. And then, when you're taking a step back and looking at kind of the whole topology of something like this, right? You have a handful of services, or however many services you have running in your cluster, and those services have Envoy proxies, or proxies sidecarred with that go along, and that's how the network communication happens. And then you have that's the east-west component of a service mesh, right? But there's also a north-south component to it, and that is, how does traffic even get into the mesh? And that can be from, say, a client. That could be from another piece of infrastructure. So that could be your legacy on-prem infrastructure, whatever. But you still need to get traffic into the mesh, right? For the east-west traffic to be useful, something has to initiate that the reason for those services to talk to each other, right? And so that's the north-south component of the service mesh. And so again, the service mesh is really popular tool for valid reasons. It solves a lot of problems. It is important when you're going through a microservices journey. But that being said, there are things that you need to consider when you're talking about a service mesh, because service mesh it's a very good tool, but it's also a pretty heavy tool, right? It's a very big infrastructure commitment to go down the service mesh route. And so there are some things that you need to consider when you're talking, okay, let's bring in a service mesh. So some of those things that are worth thinking about are, first of all, do you even need a service mesh? And I think a lot of folks are eventually going to need a service mesh. I think what we've seen, as I've been working here, as I've been talking to folks, there are a lot of valid reasons for people to use a service mesh, but maybe they're not there yet. Maybe they don't need it quite yet. And so you need to ask yourself, do I actually need a service mesh? And some of the things that drive those kind of questions are, do you have a mix of application languages or frameworks? And the reason that question is important is because most of the features that you need out of a service mesh, most of those features you can implement inside of the application, right? So one of the common use cases for a service mesh is fault tolerance. So you can do things like retries, you can do things like circuit breaking, et cetera. And you can absolutely do that in your application. So if you have if your organization is a Java shop and everyone's using Java, you have some standard libraries that you use, you could easily build your fault tolerance into the applications themselves. And, again, talking Java, right, that's where the Hystrix library from Netflix comes into play. I think that's kind of, that's been sunsetted. It's in maintenance mode, but there's newer ones like Resilience for J, right? And these are tools that provide some of the benefits of service meshes, fault tolerance, like retries, et cetera. And those are built into the actual application using these libraries, or maybe you build a custom library to do it. And so that that's valid, right? You can get those benefits by using an application library. So if you have a single language that you use, and you have kind of a standard set of libraries that you promote, you don't need a service mesh, right? You might be able to get the benefits of it without having to introduce a service mesh. Once you start talking about, okay, this team is going to use Java, this team's going to use Go, and so on, right? Then it starts to get more tricky, especially if you're trying to custom build this stuff, because now you have to implement that logic in 2 or 3 or 4 or 5 languages, and then it quickly grows out of control. So that's when you might think, okay, a service mesh might be beneficial to us. Another question that you can ask is, do I have a large amount of microservices in general? Because if you only have, 10 to 20 or so services, a service mesh is probably overkill for that. You probably don't need to introduce that level of complexity to your environment to solve 10 services communicating across each other. So, but if you know that your organization is going to grow, or you're just in general in a large organization, maybe a service mesh does make sense. Another question is, do you have lots of east-west communication in general? And what I mean by that is, think about the case where you have a single page application. That's what you're developing, right? A single page app, and you have 10 different API endpoints that are required for this app to function. If all of those 10 APIs are kind of standalone, right? So there's not a lot of communication, between them. You don't really need a service mesh because there's no reason to have that east-west component to it. You're just, making a call and you're going through maybe a gateway, whatever, and you're getting your response back to your single page client. And in that case, there's no need for a service mesh. So, the type of calls that are happening in your application, you have to consider that when you decide if you need a service mesh or not. And then finally, we call out, are you comfortable with your infrastructure stack? And the reason is because a service mesh, so again, let's talk Kubernetes, service mesh is very tightly coupled to your infrastructure, right? So when you're talking Istio, you have sidecars, you have all of the Kubernetes type of configuration, all the custom resources. You have, you're introducing a lot of additional things to your infrastructure that are very important because you're talking, service calls, right? So if something goes wrong, you could very quickly be hurting from an availability perspective. And so when you start looking at, are you ready for a service mesh, having a good grasp of your infrastructure is very important. And so then once you decide that, what, we do need a service mesh, there are some challenges that come with that you should consider, as you're going through that journey, right? So one of them is, which one to choose. So we already mentioned Istio, but there are quite a few service meshes out there. I will say that Istio seems to be kind of the most popular one right now, but there are lots of other ones. And for example, your decision may come down to what platform you run on. So if you're an AWS company, an AWS shop, and you're committed to running everything on AWS, it may make a lot of sense for you to choose App Mesh, right? AWS App Mesh, which is an Envoy-based mesh. So if you're using managed AWS services, why would you not use a managed AWS mesh? So picking the right one is also something that you have to consider. And maybe you don't want to, the famous vendor lock-in term, right? That might be something that will sway you, but making that decision is important because migrating off of a service mesh is not something that's trivial, right? So you want to, you need to pick the right one, but at the same time, you don't. Basically, what I'm getting at, it's challenging to decide which mesh to use. Then it kind of related to that is who's going to provide support to it. And this is probably more relevant to bigger enterprises or companies that have regulatory reasons for requiring enterprise support. Basically, do you need enterprise support for your mesh? And if so, how are you going to get it, right? So this may kind of be an easy decision for you if you're talking so for example, if you're running OpenShift, right? OpenShift has its own flavor of Istio. I think it's called Red Hat Service Mesh now, and that comes with your OpenShift. So you may already have the choice made for you. You may decide, okay, I need to go Red Hat Service Mesh, and then I'm going to have them support it. But then what if you want to use a feature that's in the newer version of Istio that's not in Red Hat Service Mesh? So it's kind of there's a little bit of trickiness there in deciding, okay, which one and who's going to support it. Another challenge is multi-tenancy. And the reason this is challenging, if you don't have a multi-tenant environment, then this is probably not relevant. But for some folks that do have multi-tenancy in place, figuring out how you're going to solve that with service mesh is challenging, because are they all going to participate in the same mesh? How do you ensure that they can't talk to each other? Then you get into things like, okay, am I going to use a Kubernetes network policy in addition to my mesh? So things can quickly spiral out of control if you don't kind of have a grasp of your tenancy up front. Managing multiple clusters is an interesting one. So there are many reasons why you may use multiple clusters. The most common of which that I can think of would be if you're running for high availability, you have kind of replicated clusters in different regions, right? And so you have a mesh, you have a cluster in US West and a cluster in US East, and you have a mesh installed in both of those, but it's really the same mesh. What happens if you want to perform a failover, right? Are you going to perform the failover at the service level? Are you going to fail over all traffic? So multiple clusters come into play for various reasons, and figuring out how to do that with a mesh can be challenging. The next one would be delineation between developers and operations. This is kind of a nebulous one, but ultimately, when you start talking about some of the features of mesh, right, the lines get a little blurred between developers and operations, and that in general is the case kind of with the way that everything's going, right? The whole DevOps model, and it makes a lot of sense. So if you're going towards a microservice approach, which probably means you're going towards a team will own from top to bottom their application or their service, that means that they're probably responsible for the quote unquote operational component as well, right? So now it may make sense for them to own all of the configs, right? So they own the fault tolerance configs, they own the security configs, but if not, basically figuring out who will own what in a service mesh gets a little blurry. And then finally, legacy hybrid environments. In most cases, we don't have the luxury of going pure greenfield, right? So you have to consider your legacy environments. You have to consider working in a hybrid model. You have to consider on-prem and public cloud. And so when you're going service mesh, what do you do about those legacy environments? Are they part of the mesh? Are they not part of the mesh? If you do want them to be part of the mesh, depending on which mesh you choose, that can be a tough problem to solve. And so, really what I'm getting at here is just, service mesh is great. It's just there are a lot of things you need to consider, and it's not just, okay, let's just say we're going mesh and then it will start working, right? There are some challenges and problems you'll need to work through. And then, one of the things that you'll consider, this is kind of fun, but really when you're talking, okay, now we have a mesh and now every service can talk to every other service, you can quickly get into this Death Star architecture where if you have no kind of logical separation of the services, now you get into this unmanageable spaghetti ball of how to, service can talk to anybody else, and it really becomes difficult to even make sense of what's going on. So that's something that you definitely want to avoid as you go down the mesh journey. So then, what are some options that help with kind of this? Okay, we want a service mesh, maybe we're not quite ready for one, or you're going down the journey and it's you don't want to fully commit. You say, okay, we're going to install the mesh in our cluster and we'll figure it out, right? You want to have more of a kind of a specific path forward, right? So one of the options that we've seen here at Solo that works with pretty good success is kind of a gateway approach. And so basically, starting at the edge and starting with a single gateway that can help you in your journey. So you're putting a gateway in the path of, okay, so we're going, let's say you're going some new services, or you're migrating an existing service, and that's going to be kind of your basis for your cloud native or your microservices model. So you have a bunch of on-prem stuff, and then you're rewriting one of those services, and that's going to be your your new infrastructure, right? So if you start with a gateway model, right, you can put something at the logical edge of that infrastructure, and that's something that you can use to kind of augment and complement the existing setup. And so now you can start routing traffic to that gateway, and that gateway can then route to the new services. And then as you want, you can start replacing some of the existing infrastructure. So rather than routing to maybe a legacy gateway or whatever, you can start using your cloud native gateway to, okay, we'll call the gateway, we'll route some traffic to our greenfield, and then everything else will still use that new gateway to route to our existing infrastructure. The benefit of doing that is now you're starting to target multiple environments, but you also are reducing the blast radius. You're providing as little disruption as possible. And what we see is that when you go down this path, the data plane that you pick, the gateway implementation that you pick, is very important. And so no surprise there, we're saying Envoy is probably going to be your choice, should be your choice. Because, as we talk service mesh, as we talk, the kind of the the trends of the industry, Envoy is, by and far becoming the go-to for that kind of, for a proxy in a cloud native world. And it's also important to pick something, like the whole point of this is to get to service mesh, right? You want to pick something that lets you adopt that in an iterative fashion. And so you want a gateway that understands service mesh, that can talk to service mesh. And that kind of goes alongside with the fact that if you choose Envoy, right, you're running the same proxy technology, you're running that at the edge and inside of the mesh. And then one of the things that's worth considering, right? So we're talking the journey from service mesh, or from no service mesh to service mesh. And we're saying, okay, we want to introduce a gateway. Either way, there are different concerns when you're talking, okay, what's inside of the mesh versus what's at the edge. And we'll go through some of those right now. So again, the edge kind of represents that north-south traffic, right? So you have a client or you have a legacy component, whatever it is initiating a call to a service that lives in your mesh. That north-south component is what we're talking about right now. That's the edge. And so there's definitely some overlap between north-south and east-west. There's overlap between the functionality you need in your mesh and the functionality you need at the edge. And so traffic control and routing is kind of a no-brainer, right? You need to be able to route your traffic. You want to control that. TLS, MTLS, very important in general. As we talked about, as you're going to a hybrid world, as you're going through to everything is a network call, network encryption is very important, right? That's one of the MTLS piece is one of the main benefits of using a service mesh, right? Now you can get, you can ensure that now every single network call is really not only going to be encrypted, but you're also validating the clients, right? So you can very fine tune, very much control, which clients can talk or which services can talk to each other, right? At the edge, you still want that level of control, right? Maybe you don't need MTLS at the edge, but you definitely want to be able to, from a downstream perspective, but you definitely want that to be network encrypted. And then you also more than likely are going to want your edge component to be able to MTLS into the mesh, right? Otherwise, it's not going to be able to participate in the mesh. Observability, for all the reasons we've talked about, is very important, and you don't want to have a missing hop, right? So you want an edge component that can participate in the same observability that the mesh can. And policy enforcement kind of goes alongside with the TLS, MTLS piece. This time you want to make application layer decisions, right? So let's say you're using JOTs. If you have an environment where the JOT that's used at the edge is the same as the mesh, then that's perfect, right? You can just you can enforce that the JOT's present on an ingressing call and then pass that along, and every single hop can validate that. And there are lots of other ways to do that, right? So open policy agents becoming more popular, but there are a lot of ways of enforcing policies, right? And you're going to want to do that. Maybe they're not the exact same enforcement, but you're going to want to do that at the edge as well as in the mesh. But there are also things that you need to consider that are edge level concerns that are not terribly as important inside of the mesh. So the first one here, OAuth and OIDC, I'm going to mainly focus on OIDC for this. So a lot of the time, one of the common use cases for ingressing into the mesh is from a user-based request, right? A user-initiated request. And so I'm a user, and I'm in my browser. I'm using my browser is my user agent, and I'm going to access my website. The website of the company that is implementing the mesh. That initial call, that OIDC component is user facing, right? It's not something that's going to happen inside of the mesh. It's something that happens as a call ingresses into your cluster. And so at the edge is where you more than likely want to do OIDC, right? And so that's not something that is, that's not something that's not really a mesh concern. And not only that, there's not really an accepted or standard way of performing something like OIDC within the mesh. I'll caveat that there and say that there actually is some cool work being done to do that, but it's not quite there yet. Web application firewall is similar. A lot of the times your concerns there are user data, right? Either untrusted user data coming into your system, or the user data that's going, or the data that's leaving the cluster, right? So you usually want to WAF at that edge layer to be able to inspect that traffic, and you want to deny a cross-site switching request or something like that. Not terribly important inside of the mesh. The next two, message transformation and the API surface, those are related. So with message transformation, what let me start with the API surface one. So a lot of the times the API that you're exposing at the edge of your environment isn't necessarily a one-to-one mapping to the internal implementation of that API, right? So you have, the way that you're implementing the service isn't necessarily what you want to expose to the world, right? You want your API to be defined for ease of kind of, communication, right? But the internals may be something different. And so an edge concern is, okay, one, how do I expose this API, in a user-friendly way? But then you may need to transform the message. So if someone is making a request to your API, you may need to massage that request to fit the internals, right? And that's usually done at the edge. Another example of kind of message transformation, let's say that you have a JOT that, or a JSON web token that's on the request, and that's how you're performing some sort of authentication or even authorization. And the concern at the edge is that you need to make sure that a certain claim is there or something like that. And so you could do that at the edge, but then you may have a need for that claim later on inside of the mesh. And so what you could do at the edge is, okay, I'm going to validate this JOT is present, but what I'm going to do is I'm also going to pull out the claim here and I'm going to add it as a header. And then that header will be present inside of the rest of the mesh call. So you don't have to, you can easily do what you need to do with that data without having to worry about doing it at every single hop. And then rate limiting and other kind of security concerns, there may be use cases where you want to perform stuff at the edge and the edge only, you don't want to do it every single time. So domain specific rate limiting, for example, if you have a rate limit that applies to the domain or the API that you're exposing, right, you will do that at the edge rather than inside of the mesh. And so the kind of the way that we see it, as the way that we see solving these problems at the edge, is to use Envoy Proxy as the gateway. And Envoy, we've talked about it already a lot. Pretty awesome piece of software, CNCF graduated project. The more and more I work with it, the more and more I'm impressed by it. But so we at Solo think that using Envoy as your gateway is a great choice for this kind of journey, because more than likely you're going to be using it in your mesh. And so, what the value of Envoy, there's a bunch of stuff. In this case, a lot of these are what you could call kind of table stakes for proxies. But there's also a lot of cool things that Envoy does pretty much better than the others. And so like the customizable load balancing, fault tolerance, shadowing, rate limiting, all that stuff, those are all really good features. The one that I really want to talk about is the last one, the first class dynamic configuration. And the reason that that's important is, Envoy was kind of designed, and granted, I'm not an expert, but Envoy was designed from the ground up to support dynamic configuration. And that's really important when we're talking kind of this microservice cloud native world, because of the fact that without that in place, you're kind of stuck in, so most of the older proxies were, most older technology in general was built to work off of static configuration, right? So you have a config file that's some sort of text file or some sort of whatever format, and that's what configures the proxy. And then if you ever want to change it, you need to update that file, and you need to reload the proxy. So in HA Proxy, for example, they have some cool stuff, and I'm sure other proxies do it. But HA Proxy, right? You can modify your config file, reload it, and then there will be cool thing. It will do a cool thing where it tries to pass the open connections and to the reloaded process. So you can in theory not get any downtime, but you're still reloading that process, right? So there's a time frame where you're not getting updated configuration, and the other proxies are building in this functionality, because they realize that everyone realizes that in a cloud native world, like let's take Kubernetes, pods are coming up and down at all times, right? You're onboarding new services, you're removing stale services, your pods are moving around from, you're performing node maintenance, so you're killing nodes and moving pods around. So things are changing constantly in one of these cloud native Kubernetes environments. And so in order to actually provide value, the proxies that you use need to be able to accept those configuration changes dynamically, right? And Envoy was designed from the ground up to support that. So you can configure Envoy statically, and that's something that we'll look at here in a second, but you can also do everything that you can do statically with a dynamic API. And that's really powerful that's how Service Mesh works, right? That's how using Envoy as a gateway works, because they're getting dynamically configured according to the state of your infrastructure. And you don't have to worry about, reloading processes and making sure that connections are passed around, et cetera, right? You get the benefits of the fully dynamic infrastructure inside of your proxy. And so this is kind of like the summary of like what we'll use Envoy as when it comes to a gateway, right? So you introduce that API kind of tier at the front side, downstream of Envoy, but then you get all of the benefits of Envoy on the backside. So in this example, right, we have an API that's exposed, and it may route to the old monolith, or it may need to do a gRPC call to service A or a WebSocket call to service B. And maybe you want to do some percentage of traffic, like a canary or blue-green or something to service B prime, right? So you get the benefits of Envoy, but you also get the benefits of an API gateway where you can expose an API and perform API management and things of that nature. And so at Solo, we have a component called Glue. We have a tool called Glue. And really, it's a control plane for Envoy. And, just like Istio is a control plane for Envoy, and there are many others, Glue is one of those. And the really important part here is that using a control plane enables you to use Envoy in a variety of environments and enables you to use it for the cloud native microservice world. And so this kind of shows, the Glue is intended to run pretty much anywhere, and it can understand configuration, or it can pull configuration from a variety of locations, Kubernetes or console or flat files. And since it's just a simple container, it can run anywhere pretty much. And then it dynamically will configure your Envoy data plane to match the configuration that you have set. And so finally, one of the sections that I'm going to kind of skim through this, but it is important to kind of at least visualize it. So kind of the initial adoption pattern that we've been talking about is using an Envoy edge gateway or edge proxy, right? So in this case, we have Glue as the control plane and Envoy as our data plane. We have a handful of services that are running inside of, let's call this a Kubernetes cluster. And we have 5 services here that are running in 3 different namespaces or something, right? And so if you only, your first step, you probably will not have that many services, right? This might be an accurate representation of kind of that first step. And so Envoy can act as your edge proxy with also some API gateway functionality and handle the ingressing to those services. But then, maybe you're growing your environment and you start introducing a bunch of workloads because you're happy with how the Envoy and how your Kubernetes migration is going. And maybe you need to start introducing some decoupling points, or a multi-tier gateway is kind of what this can be called. And what this means is that now, rather than so now you start having east-west calls in some form or fashion. So you start having services calling other services that, in this case, let's say the blue. Let's see if I can do this. Yeah. So you have this blue these boundaries. We can call these namespaces, but we could also call it like okay. So this is the search team's namespace, and this is accounts and billing, right? And so as you start introducing services, as you start needing services to talk to services in another namespace, rather than having them talk to each other, you can call the gateway that corresponds to the tenant or the domain or the boundary, however you logically want to break this up, right? And this is going to be very dependent on your organization, your architecture, but the important part is really that using gateways gives you flexibility, right? It gives you decoupling points because it allows you to introduce a point where you can control the traffic, right? And whatever that means in your environment, you can do that with strategically placing gateways in your architecture. And then kind of going one step further, this is kind of very a loud slide, but when you start talking about having a service mesh, let's say that you have 3 different service meshes, whether or not it's the same cluster, that's fine, but you still have kind of your initial ingress tier, right? And since the traffic's flowing through here, you get the flexibility to route the traffic however you want. And then, again, you start having service east-west traffic, service calls inside of your meshes. But rather than having everything in the same mesh, or rather than having everything know about all the other services, these decoupling gateways allow you to introduce logical separation, right? And so this is how you can this helps you avoid that Death Star architecture that we were talking about earlier, where, if every service calls every other service, it can quickly spiral out of control. And so having flexible decoupling points allow you to get a grasp of your architecture and put logical boundaries in place. And then kind of looking forward, so Envoy, again, an awesome tool. And it also helps enable some pretty cool capabilities in the future. And the future is not that far off at this point. So this is one example where, a couple of other tools we have at Solo, at least, where as you start growing your gateway and mesh deployments, right, you probably are going to want tools to help manage those. And so, federation of gateway and federation of mesh is going to, we think, going to become more and more important. And so there's some options there, but really you can utilize some of the awesome features of Envoy, like, for example, locality awareness, to be able to handle things like failovers, where you can say, okay, I want all of my service calls to stay local to one mesh, or one, whatever that boundary is. But if a service goes down, I want to be able to fail over to another one. Or if I have a zone outage, right, I should be able to fail over. And so you can, as you start introducing smarter tools on top of something as powerful as Envoy, you get to, talk about the federation and the failover. And, Envoy enables us to do that. And then another really, really cool piece of technology is WebAssembly, and specifically extending Envoy with WebAssembly. This is actually something that just recently landed in upstream Envoy, where now you can, so the main way that you configure, you extend Envoy is through writing filters for it. And so now prior to WebAssembly, in the current state, really, you need to write an Envoy filter as in C++, and you need to build that into the Envoy binary. But WebAssembly allows a way for you to not only use C++, but any language. In theory, any language, but in reality, it's any language that can compile to the WebAssembly that Envoy expects. But you can write filters in your in whatever language. So, like, let's say assembly script, which is pretty much JavaScript, but it's something that targets WebAssembly that works in Envoy. But you could write a filter in assembly script, and then you can dynamically load that into Envoy, so you don't have to build it into it. So it's really what it means is that now you can start becoming very, you have a lot of customization and extendability. It opens up the door for a lot of that, because now you don't have to compile it. You can start writing modules and sharing them, and you don't have to rebuild Envoy. You can just dynamically pull them in. So this is going to open up the door for a lot of customization of Envoy, and it's really, we think it's going to be really powerful, because we think that, so as we work with folks, that are using Glue or any of our other tools, one of the things is that they have a specific use case to them that, honestly makes a lot of sense for their organization, but it's not something that we would build into our products or build, so we wouldn't take that functionality and build it into a general purpose filter, for example, because it doesn't quite make sense in any other organization. And the reason that they don't want to do it is because there's, it's not, the barrier of entry is fairly high. You need to write C++, and you need to take on the build process yourself. But the WebAssembly capabilities kind of, break down that barrier. And now you can quickly on your own, as an organization, customize Envoy, customize your proxies as you see the need to do so. Okay, so that's pretty much it for the slides. And now we'll get into a demo. Go ahead and get out of that. Okay, we're running okay on time. Okay, so give me a second. Okay.
You will definitely, yeah, there you go.
Yeah, absolutely. Let's see here. Get these. Okay, so for a quick demo, what I want to show is the key to all of this stuff is Envoy, right? And so in order to really understand what's happening is we need to understand how Envoy works, and we need to understand how to configure Envoy. Again, one of the main value propositions of Envoy is the dynamic configuration. And so what I want to show is kind of the static configuration of how you initially get Envoy set up, and then kind of look at how a tool like Glue or any of the other control planes help by making by dynamically configuring Envoy according to the state of your environment. So what I have here is, so I'm running a Kind cluster right now, which is an awesome tool, by the way. And I have an Envoy image that I built that contains a static configuration file. And so we'll take a look at that here. So this is it. It is what, 48 lines of configuration. And really quickly going through this, what the environment that I'm setting up, I have a simple JSON style API that's called pet store, and it just returns some JSON. And what I want to do is route to it. So in this case, you know, what I do to set up Envoy is I have a set of static configuration, because again, there's nothing dynamic here, right? It's completely static. And then the first thing I have defined is a listener. And this listener is a listener in Envoy really corresponds to kind of the network location, or it doesn't have to necessarily be a network location, but the place where, you know, it will accept downstream connections. And so in this case, what I'm doing is I have a TCP downstream listener that will, it's binding to any address, right? So, and then I'm listening at port 10,000. So what I'm saying is I'm going to accept connections at port 10,000 for TCP traffic. And when a request comes in, or when a connection is established, now this listener configuration handles it. And then in Envoy, you know, we mentioned filters. The standard way that you configure Envoy to work is by configuring the various filters that they have. And so there's a concept of a network filter, which operates on kind of the low level, you know, in this case, TCP, right? Which is really just moving around bytes and stuff. But here we have a network filter that's called the HTTP connection manager. And that is how I actually, you know, that's how I actually do HTTP style processing. And so this network filter then gets configured with one important thing is the routing config. So this is the route table, right? And this is very basic. There's a single route. And the important part to look at is my route this route will apply for any, I'm setting up a virtual host, and the domain for that virtual host is star, which means anything, right? So any domain, when an HTTP request comes in and the host header has anything, this virtual host applies. And then I have a single route, which I'm doing a prefix of /. So this is a path prefix of the root path, which essentially means any request, right? So for any request, again, on any domain, what I want to do is I want to route, and I want to route to a cluster that's called pet store. We'll get into the cluster here in a second. Then I have an HTTP filter set up, and the HTTP filter is important because so we just talked about network filters. Now, once we want to actually do things, you know, handle HTTP style events. So let's say we have just decoded the headers, you know, there's something that needs to happen, or we just decoded the body and there's something that needs to happen. The router is a special HTTP filter because that's what actually does the routing of so as a request comes into Envoy, then Envoy says, hey, I need to route this request somewhere else. In this case, I need to route it to the pet store cluster. And then for the cluster definition, which, you know, an Envoy is really just, that's the destination for the traffic. And so we're setting up a pet store cluster. The type, this is kind of the service discovery type. In this case, we're using strict DNS, which means that based off of, if we look down here, based off of the host name for this cluster, Envoy is going to asynchronously resolve this name. And again, this is going to run in a Kubernetes cluster. So it's going to resolve against the service name of this service. And it's going to get, in this case, it would get the service IP. And so based off the IP that I've gotten for this service name, that is my endpoint, or those are my endpoints that I'm going to route to. And then the port defines, you know, based off those IPs, given that IP and port combination, those are my endpoints that I can load balance across. And then finally, there's an admin interface that's defined here. That's not super interesting, but we can look at the admin interface. So with that configuration running, if I look at I have 2 pods running in the default namespace, or 3 actually. So I have 2 replicas of my pet store, and then I have my Envoy pod. So what I'm going to do now is actually, let's do this. I want to port forward to my Envoy pod. And again, I set 10,000 as the listener port. So now that I can access port 10,000, if I were to curl to localhost 10,000 and then /API/pets is the path that's specific for pet store. But again, my routing config said any path, right? So it's going to forward that request to the pet store application. So when I curl this, now I get my response, and Envoy is what fronted, it was acting as a front proxy for the pet store. And then really quickly, what I also want to do is now if I look in the Envoy configuration, so I'm going to port forward now to that, that admin interface, which was at 10,001. Now, if I, in a browser, go to localhost 10,001, so here, there's a lot of cool stuff in this admin interface. What we're going to look at is the cluster definition. So here in the cluster definition, we defined our pet store cluster, and we defined the pet store cluster to resolve the pet store service name. So you can see here that there is a pet store cluster and there is an IP address associated with it. So if we really quickly go over here, and if we check what our service IP is, you'll see that pet store is 10.111.174.20, right? And so that is the IP address here. So we have asynchronously resolved the service name to get the service IP address, which ultimately behind the scenes corresponds to a set of Kubernetes endpoints. So what it's really doing is, Proxy has set up some IP tables rules that say when you make a request to this IP, I'm really going to forward that connection, those packets to another endpoint, which is my pod. And so by using the service name and defining that as my cluster, now I'm going to go ahead and route to the actual endpoint. And so looks like we're pretty close to time. I'll go ahead and stop there, and if we have more time, I can keep going. But I'll go ahead and stop there and see if there's anything we want to talk about right now.
Yeah, well, so this would be a great time for anyone who has questions to go ahead and put them in the chat. Lawrence, that was awesome. Thank you so much, especially for the demo. Hopefully everyone could see it. And of course, this is being streamed on YouTube and should be available shortly after for people to play back and whatnot. So please leave any questions. There's none right now.
Okay.
So I'll ask a question, and this is really maybe kind of oddball, but what is your take on the current state of the world when it comes to adoption around these things? I think, Service Mesh maybe came a little bit early and promised to solve problems that people might not have been having yet. And I think that's kind of the general feel in a lot of cases. I'm sure if you ask a kind of majority who's using Service Mesh, who's worked with Envoy before, especially in more production environments, the answer is probably not many, right? What do you see as the next year or two? What does the evolution look like? How are people going to start leveraging this? And what do you think the biggest needs will be when they do?
So that's a great question. I think you're spot on as far as like Service Mesh kind of maybe coming a little too early. It's been talked about for a while now, and it definitely does solve problems. But I agree. I think that the real problems that you have aren't necessarily the problems that it's trying to solve are not problems that most folks will have ran into yet. So I think it's completely valid, and that's actually why we kind of suggest the gateway model, because you can get a lot of the benefits of what a service mesh can provide if you're using in our case an Envoy based gateway. And so what I think will happen, we have lots of pretty big customers that are starting to get serious with, okay, let's either go with a service mesh or let's get serious about using, for example, Glue, or really just let's use Envoy in production. And I think that that's really starting to pick up. I would say that, in the next year or so, I think that adoption is definitely going to continue. I think as far as service mesh goes, I think that a lot of organizations are flirting with it. And over the last year or so, I think that kind of flirting has happened. But I think that it's starting to get to a point where people are going to start really using it in production. So I know of a couple, and I know of more that are seriously thinking about, okay, how do I really make this happen in production? And the reason is, as they've decided to, architecturally decided, let's go down this microservices approach. The problems that service mesh promises to solve, they're real problems. It's just they haven't ran into them yet, right? So as their kind of array of microservices starts growing, the need for a service mesh makes sense. And that's kind of where, in the talk we were talking about, like the challenges and the considerations. If you look at the service mesh with those in your mind as you make those decisions, it definitely makes sense that you will be able to you'll be able to solve the problems without shooting yourself in the foot. So I personally think that, based off what I've seen, I do think that given the state of the industry, you will see more and more service mesh adoption. I don't see that going away. And I think that in the next year that will start to increase.
Awesome. Thank you for the in-depth answer. And, I kind of agree, not that I am anywhere near as close as you guys are. And I think what Solo is doing for people who are trying to adopt this is great, because it gives them clarity and some tooling around it, and it makes it easier to digest. Me having kind of a networking background, I really kind of clearly see what this brings to the table, right? It's a lot more control and a lot more of uncovering the shadows of network traffic and what you can do with it, service to service and whatnot. So that's great to hear. It looks like Steve is typing, but he's still typing. So in the interest of giving everyone their evening back, Lawrence, where can we learn more about you? What's, maybe Twitter or social media? How can we talk to you?
So I am not too into social media, at least not yet. But I hang out in Solo Slack. So we have a pretty active Slack. If you're interested, please join. And we can maybe we can send out some links or something. But we have a pretty active Slack, so I'm hanging out in there. And then we're trying to still go to meetups. I think you kind of alluded to it earlier. I think kind of people are getting a little tired of the virtual events. So hopefully, when the world starts going back to normal, we can start meeting people in person and hanging out and talking about this kind of stuff. But yeah, I can also send out my email, and then come to the Solo Slack. It's pretty active, so come join us.
For sure. Awesome. And yeah, you can shoot me your email at some point, or someone on the team, and we can definitely kind of shepherd it to people who have some more questions as well. Awesome. I want to say, from everyone on the team and everyone who watched today, thank you so much. You've given the introspection into something that a lot of people are just starting to understand and don't really fully get, but there's just this strong interest for it. And so you've really kind of given us a 0 to 100 of what the lowdown is and what the possibilities are. So that's fantastic. All the best with Solo, with your team, and hopefully things are growing for you even throughout this pandemic. So from me personally, I want to thank everyone again. We will be in contact. Don't worry. Things are going great for each of us. We all are still working and doing what we can in the cloud native ecosystem. So thank you so much. And there's been a couple, just one question that came in. I'll get that to you later, Lawrence. Okay. But feel free, if you have any more questions or you just kind of want to chat with Lawrence, let me know, and we'll connect you guys, of course. So thank you so much, and we're looking forward to at some point meeting you in the future in person. I would love to hang out with the Solo guys, get some drinks too. Absolutely, guys and gals. So thank you so much for participating and helping make this meetup happen. So take care, everybody. That's it for me. Jeff and Bob, of course, thank you for your help. Without you, this would not be possible. Thanks to everybody watching, and have a great rest of the year, holiday, conferences, and talk to you soon. Bye-bye.
Take care.